Imagine a building material that, even after centuries, could still repair its own cracks. This isn't science fiction, it's the genius of Roman concrete. For over 2,000 years, structures like the Pantheon have stood, their massive domes defying gravity and time, thanks in part to a revolutionary material whose secrets eluded us for millennia. Recent discoveries, notably by MIT researchers in 2023, have finally begun to unlock this ancient marvel. The Romans intentionally incorporated quicklime chunks into their concrete mix. When cracks formed, water would seep in, reacting with these lime clasts to create calcium carbonate, effectively filling the fissures. This self-healing property is something modern concrete, despite all our advancements, struggles to achieve on such a scale and with such longevity. The Pantheon, a testament to this lost art, has a concrete dome that remains the largest unreinforced concrete dome in the world. Its survival is a stunning indictment of how much advanced knowledge the ancient Romans possessed, knowledge we are only now beginning to understand and replicate. The implications for future construction, for creating truly enduring infrastructure, are immense. But this was far from the only secret buried within the ruins of the ancient world. Picture a blade so sharp, so durable, it could slice through a falling silk scarf without resistance. For centuries, the legendary Damascus steel, also known as wood steel, was the stuff of myth, its creation method lost to time. These weren't just swords. They were masterpieces of metallurgy, capable of feats that modern blades struggle to match. The secret lay in a unique crucible steel produced in India and Sri Lanka, then expertly forged by master swordsmiths in Damascus. For centuries, the precise composition and forging techniques remained an enigma, inspiring countless legends of magically imbued weapons. Modern science, however, has begun to peel back the layers of this ancient mystery. Microscopic analysis of surviving wood blades has revealed a structure containing carbon nanotubes, minuscule, incredibly strong tubular molecules of carbon. The ancient smiths, through their controlled heating and cooling processes, essentially created these structures unintentionally. This discovery is astounding because carbon nanotubes are a cornerstone of modern nanotechnology, a field we consider cutting edge. Yet, the ancient smiths were weaving them into their steel over 1,000 years ago, centuries before we even conceived of such a thing. The result was a blade with unparalleled edge retention and flexibility. But this was far from the only secret. Imagine a weapon so terrifying, so devastating, it could burn on water and was virtually impossible to extinguish. For nearly 1,000 years, this was the nightmarish reality for enemies of the Byzantine Empire. The secret weapon known as Greek fire was the ultimate deterrent, a devastating naval weapon that played a crucial role in defending Constantinople from numerous sieges, most notably in 678 AD and 718 AD. Its exact formula remains one of history's most closely guarded secrets, a testament to ancient chemical ingenuity. Historical accounts describe it as a liquid that, when projected from siphons, ignited with an intense flame, clinging to ships and men alike. It could burn even when doused with water, creating a horrific spectacle. What was this infernal concoction? Theories abound, ranging from a mixture of naphtha, sulfur, and quicklime to more complex compounds involving resins and pitch. Some speculate it contained phosphorus, which ignites on contact with air. Yet, no definitive recipe has ever been found. The Byzantines guarded its production jealously, reportedly within imperial workshops, and its knowledge died with the empire's fall in 1453. The sheer terror and strategic advantage this weapon provided, based on a lost chemical formula, highlights a level of scientific understanding we can only speculate about. But this was far from the only secret. In 1901, divers exploring a shipwreck off the coast of the Greek island of Antiquity recovered a barnacle-encrusted lump of bronze. What they unearthed would redefine our understanding of ancient technological prowess. This was the Antiquity mechanism, an artifact dating back to around 100 BC, and it was, in essence, an analog computer, far more sophisticated than anything previously believed possible for its era. The mechanism used a complex system of over 30 interlocking bronze gears. Its purpose was to predict astronomical positions and eclipses for calendrical and astrological purposes. It could even track the cycles of the Olympic Games. The sheer complexity of its gear trains, displaying an understanding of differential gearing that wouldn't reappear in Europe for over 1,000 years, stunned archaeologists and scientists. It's a mechanical marvel, a testament to the Greeks' profound grasp of mathematics, astronomy, and engineering. Think of it, a device built over 2 millennia ago that could perform calculations and predictions with such precision, all through purely mechanical means. We are only now, with advanced X-ray technology, beginning to fully decipher its intricate workings and the knowledge it represents. The mechanism is a stark reminder that the ancient world possessed technological sophistication that rivals, and in some cases surpasses, what we might assume. It hints at a lost tradition of complex mechanical design, but this was far from the only secret. Stand before the ancient Inca citadel of Machu Picchu, or the massive stone walls of Sacsayhuaman, and you will witness stonework that defies belief. Massive, irregularly shaped boulders fit together with such astonishing precision that not even a knife blade can pass between them. And remarkably, there's not a speck of mortar in sight. This is the legacy of Incan engineering, a mastery of stone manipulation that still puzzles modern builders and geologists. How did they achieve such perfect joints with stones weighing many tons, some exceeding 100 tons? The prevailing theory suggests a process of pounding and grinding, slowly shaping each rock against its neighbor, a painstaking and incredibly skilled endeavor. The stones were meticulously cut and fitted, creating interlinking patterns that provided incredible structural integrity. But this was more than just a feat of craftsmanship. It was a vital engineering solution. The interlocking joints allowed the stone walls to move slightly during seismic activity, absorbing the shock and preventing collapse. Peru is a highly earthquake-prone region, and these ancient structures have withstood countless tremors over the centuries, a testament to their ingenious design. The sheer scale of the operation, the precision without modern tools, and the earthquake-resistant functionality represent a lost art of stone masonry that we are still striving to fully understand and replicate. But this was far from the only secret. Imagine holding a blade so sharp, so resilient, that it could cleave through armor like butter, a weapon that inspired legends whispered for centuries. This was the hallmark of the Ulfbert sword, a Viking marvel forged nearly a millennium ago. For a long time, their incredible strength and flexibility were a mystery. Modern analysis of these 150 surviving swords reveals a revolutionary construction technique, crucible steel. The Vikings, it seems, mastered a process of melting iron and carbon together at extremely high temperatures to create a homogeneous, high-carbon steel, centuries before European blacksmiths would rediscover this method. The meticulous layering and precise quenching techniques employed by these Norse warriors produced a blade that remained sharp and unbreakable, a testament to their unparalleled metallurgical skill. While we can now analyze their composition, replicating the precise artistry and the exact proportions that gave these swords their legendary edge remains an elusive goal for modern metallurgists. These swords were not just weapons. They were technological triumphs, imbued with a mastery of fire and metal that set them apart. But this was far from the only secret. Step into the shadowy realm of ancient Roman luxury, where objects possessed a magic that even today leaves scientists baffled. Behold the Lycurgus cup, a 4th century AD masterpiece that seemingly glows with an inner light. When illuminated from the front, it appears a murky green, but shine a light from behind, and it erupts in a vibrant, startling red. This isn't simple pigment. It's a feat of nanotechnology, crafted by embedding microscopic gold and silver particles into the glass itself. These particles, mere 50 nanometers in size, interact with light in a phenomenon known as dichroism. Depending on the angle of light, the nanoparticles absorb and reflect different wavelengths, creating the dramatic color shift. The Romans, without the aid of electron microscopes or advanced chemical analysis, somehow discovered how to manipulate materials at this incredibly fine scale, creating an effect that modern labs are only now beginning to fully understand and replicate. The precision required for this ancient glassmaking is astounding, a lost art that hints at a deeper understanding of matter than we once believed. But this was far from the only secret. Imagine an ancient civilization dabbling in electricity, not with wires and generators, but with simple clay pots. Unearthed near Baghdad, Iraq, are artifacts dating back to the Parthian or Sasanian Empire, around 250 BC to 650 AD, that strongly resemble primitive batteries. These Baghdad batteries are terracotta jars, each containing a copper cylinder and an iron rod, sealed with bitumen. When filled with an acidic liquid, like vinegar or grape juice, chemical reactions could have produced a small electrical current. While their exact purpose remains debated, perhaps for electroplating gold onto metal objects or even for religious rituals, the implication is staggering. Could the ancients have harnessed electrical power in a rudimentary form, centuries before Volta's famous pile? Modern experiments have successfully generated a few volts using these replicas, proving the concept's viability. However, the definitive proof of their function and the full extent of their application remain elusive, a tantalizing glimpse into a potential technological path not followed. But this was far from the only secret. For over 300 years, the world's greatest violinists have sought to unlock the secret behind the instruments crafted by Antonio Stradivari. In the hands of a master, a Stradivarius violin produces a tone of unparalleled richness, projection, and emotional depth, a sound that modern instrument makers still struggle to replicate. Stradivari, working in Cremona, Italy, between the late 17th and early 18th centuries, produced over 1,100 instruments, with around 650 surviving today. While his craftsmanship was impeccable, the true magic is believed to lie in his secret varnish recipe. Theories abound. Perhaps it involved mineral elements, specific plant resins, or even a unique aging process for the wood. Some researchers have even proposed that a microfungal infestation in the wood, unique to that era, might have contributed to the violin's resonant properties. Despite extensive analysis, including spectrographic and chemical studies, the exact combination of ingredients and application techniques that bestowed these instruments with their legendary voices has remained elusive, a lost art whispered through the strings. But this was far from the only secret. Imagine a color so vibrant, so enduring, that it adorned the tombs of pharaohs and the temples of gods for millennia, a hue that seemed to capture the very essence of the heavens and the earth. This was Egyptian blue, the world's first synthetic pigment, a marvel of ancient chemistry. Created by the Egyptians as early as the 26th century BC, it was a complex mixture of silica, lime, copper, and an alkali, heated to over 800 degrees Celsius. The resulting pigment was incredibly stable, resisting fading and weathering, and was used to paint everything from tomb murals to sarcophagi and faience pottery. For centuries after the decline of ancient Egypt, the precise recipe was lost, becoming one of history's most tantalizing chemical mysteries. Modern science finally cracked the code in the early 2000s, rediscovering the intricate process. Yet, even with our understanding, perfectly recreating the subtle brilliance and enduring quality of authentic Egyptian blue on a large scale remains a challenge, a testament to the ingenuity of artisans who worked with primal elements to create a color that truly lasts for eternity. Their mastery, etched in pigment across the sands of time, continues to inspire awe.